doesn't I can't plug a formula with rho in it in for rho. So I mean, there's nothing mathematically incorrect about that, but it just can't be my final form to plug it in because it has rho in the one side of it. Why don't we this stage here, I'm going to square both sides. Okay, so write this line down. And the reason why I'm squaring both sides is because by doing that, I'm able to break this stuff out of the square root, and then I can put the row squares on the same side. Okay, so we got up to here. I'm trying to get rho by itself because I need a formula for rho. So I squared both sides. And then I moved this term that had rho in it over here, and I can factor rho out. And so rho then would equal 6. I'm running out of room on the board, so that's why I'm doing 2 steps in one. I'm dividing by this, but then to get rho and not rho squared, I took the square root. So rho goes from the origin, so 0 is the length of rho at the origin, out to the ellipsoid surface, and the ellipsoid surface is defined by what I have there. Okay, so that was the worst part of this one in terms of spherical. Phi and theta actually are going to be fairly clean to think about. I again am going to use symmetry, but I really don't have to. Yeah, why don't on this one we not use symmetry, okay? So here's my shape, and phi is being traced from the positive z-axis. Okay, I'm tracing phi from the positive z-axis. So at the positive z-axis, phi is 0. If I keep rotating until I get to the bottom of the ellipsoid, phi would be pi. I would rotate a half circle. And then theta would go 0 to 2 pi. If you did use symmetry and you only did the top half, then phi would go from 0 to 90 degrees, or pi over 2. Okay, so phi, if I use symmetry and I only use the top half, then phi is going from 0 to 90 degrees, but in radians 90 degrees is pi over 2. But I didn't use symmetry, so to trace the bottom part of it, phi is going to go from 0 to pi over 2 all the way down to pi. Yes?
But how is that possible when it's not a circle? I don't know if pi was that.
Well, because the rho changes according to the formula. You're changing rho according to the 4 divided by the square root of. So as you trace, so like rho is its longest here, it'd be 4, because phi would be 0 at that point. So cosine squared is 1, but the sine squared is 0. So you get 4 with square root of 1 would be 4. But then as you change phi, rho is changing. So rho gets shorter, and rho is the shortest it is here.
still doing the circle, it's just that it's a different shape, so that,
Yeah. Well, yeah, your phi is tracing a circle, but as you trace the circle, you change row. You change what row is. What pi over? Oh, yeah, because at pi over two, see, sine is one at pi over two, and cosine would be zero. So you have 4 times one, so when phi is pi over two, row is only two. And then it will get to be 4 again by the time you get down there. But yeah, that's a good question. I mean, that's the kind of stuff you want to picture as you're trying to piece these together.
So it's not becoming some constant that we get to carry through, it's just gotta be some variable.
Yeah, the simplest shape to set up a volume for in spherical is a sphere itself. So if you were, I mean, if you had a sphere with a radius of 4, the volume of it in spherical coordinates would go just 0 to 4. You can do 0 to pi, and then 0 to 2 pi. That would be how you would set up a plane sphere. And because the radius stays constant for the outside of the surface, your row going from 0 to 4, it's gonna always be 4 all the time. But this shape, as Liam, you were saying, is not a perfect sphere, and so the row had to change value by being traced by that formula. Okay, out of these 3 methods, the cylindrical is going to be the easiest one to work out. So let's work out the integral in cylindrical, and then we can use Mathematica to try to type in the other ones and see if we get the same thing, okay?